let's see how much we can do without our flashcards. So practice quiz 1 is right on top. There's 6 of them here. We're going to practice 6 times. So take a look at it. See if you can fill any of them in without looking at your flashcards. Just the first one. Just the one on top. Can you fill any of them? Make sure you're following your directions. Oh, let me get that. Right. What about you? Well, I fixed my attendance. Let's see how many you can fill in, and we'll go through it together. Did you notice the format of the quiz? This is exactly the way your real quiz will be. So you will have to draw 3 of them. So on this one, the ones we're drawing are this one, and this one, and this one. Could you draw any of those without looking at your note card? Do you know any of those?
Absolute value.
Absolute value is a V. Yep. Absolute value V. So hopefully you can sketch that one in.
Is the square root one like a line?
It's actually not a line. The square root one is the one that goes up and out like this. So it has a curve to it. That's the square root. Which one's this? This is the exponential, and it's a little harder. You have an asymptote here. You have the 0.01, and then you have the picture that looks like that. Now, for the next one, I actually drew the pictures for you, and now all you have to do is write the name of the function. Again, B is greatest integer for sure. Greatest integer, that is B. Gabby?
Is A logistic?
A is logistic, it absolutely is. And remember, we're not abbreviating that word. Don't write log. You have to write logistic. How about that last one? You know that one. That is the squaring or quadratic. So you can write squaring or you can write quadratic. You don't have to write parabola, the squaring or quadratic. Now 3 is the same thing. Only what are we doing now? We're writing the equation. Okay. What's A? It's linear for identity, and it's y equals x. Right? What's the next one?
Y equals ln.
It's y equals ln x. That's your logarithmic function. watch the last one. It's either sine or cosine, right? Which one is it? Cosine. Y equals cosine. Because sine goes through the origin. This one doesn't. This one starts up at the top, so that's cosine. Now this last one is the hard one. How many flashcards do you have? 12. And right here, so far on the quiz, we have covered 9 of them. 9 of your flashcards are up here. So now you gotta think, what are the 3 that we're missing? Cubing. We haven't done the cubing function. Now, for this last one, you are going to draw a name or write the equation. So I wrote the name, cubing, but if you didn't remember cubing, you could do x cubed, or you could draw a picture of it. Anything goes on this last one. All right, what else? Sine. We did cosine, but we didn't do sine. Reciprocal function. So on this particular practice quiz, those are the 3 that got left off. Alright, let's go to the back of that where it says BFF practice number 2. And notice it's exactly the same format. It's exactly the way your quiz is going to work. Anybody able to draw any of those without looking? Levi?
Like B, like start at 1 and you go
Yep,
down.
B is your cosine, that's your baby, and it starts up here because it's a cosine. So there it is, there's that's your cosine. Emma?
Is A the one where it's like on the left side and straight, but then it curves up?
Yep, so A is your logistic function, and remember the logistic function has an asymptote at 1 and an asymptote at 0, and then it squiggles up in between those. It's trapped in between those. That is the logistic function. What's that last one? 1 over x.
Would that be just a straight line diagonally by 1?
That would be y equals x. What's y equals 1 over x? That's the reciprocal. So that's the one that has an asymptote on each axis. And then you remember what else does it have? So this one, this is the top, will get you in the book.
Right. No, but I'm gonna find out why before I leave, because then I'm not gone, I'm gone after tomorrow.
Thank you, Mrs. Weaver. This is Wheeler, takes care of me, she got me a new one here. This one was the original, back when we started lanyards, I don't know how many years ago. So she saw it the other day and she said, all right, so, did you figure out your reciprocal function? It looks like this. That's your reciprocal function. Right? Okay, now we're gonna name the functions. Okay, here we go. We're gonna name, did you bring a pass in or something?
Yeah, I handed it
Alright, so name the functions. Now, I heard somebody say y equals x. That is absolutely correct, but that isn't the name. That is the equation. Now, on quiz day, if you do that, if you can't remember the name, but you know it's y equals x, you'll get half credit. Alright, so write down, if you know part of the answer, write it down. But, to get full credit, you have to write the name, and this one is the linear or identity. Sometimes it's easier for you to remember linear because it's a line. But it's also known as the identity function. What's the name of B?
Square root.
Square root. And anybody know the name of C?
Radius integer.
Okay, we good? Now we're doing the equation. So these will all be y equals. But again, if you can't remember the equation, but you can remember the name, write the name down. See what partial credit. All right, anybody know any of those equations? What? ln x is the first one. ln x, logarithm. Perfect.
The second one's the y equals the
Absolute value.
and y equals x cubed.
X cubed. And now the card section. You have 9 of your flashcards up here. There are 3 that aren't up here. And you name the 3 that aren't up there. Which one? Sign? Sign isn't up there. So I'll do equations. This is
Quadratic.
y equals sine x. Quadratic's not up there. The quadratic would be your parabola, right? X squared. Exponential's not up there. Okay, all right, one more, we'll do one more, we'll do number F today. So, here we go, take a moment, see if you can sketch these guys. I think we just got done sketching 1 over x, didn't we? What's 1 over x look like? It's a reciprocal function, so it's got the 2 asymptotes. here, and a curve up here, or down here.
What if we didn't put the asymptotes? Would that be considered
Half wrong,
Half?
missing half the picture.
Yeah.
Why would you not, Levi? They're part of the picture. Put them in there. All right, what's the next one? It's the greatest integer. Now this one's tough to draw, so make sure you're drawing it correctly. Start with a closed dot at the origin. Closed dot at the origin. Go over one and put an open dot. And then step up, put a closed dot. Over one, open dot. Step up, close dot, over one, open dot. This is the backwards too, if you want to. Gotta have 4 or 5 of those guys on now. And what I will be checking for, the picture doesn't have to be perfect, but you have to have a closed dot at the origin. So make sure you're starting at the origin with a nice closed dot. And then C is an easy one after that. C is the absolute value. All right, here we go. Write the name. What's A? Logistic, right, logistic. What's B? Exponential. And C.
Cosine.
Cosine, yeah. Okay. Now equations. What's the equation for A? Y equals X. That's your linear function. Y equals X. What's the equation for B?
Y equals X squared.
X squared. That's your quadratic or squaring function. Y equals X squared. And what about C? Be careful. Which one's that?
Element.
ln x. That's your logarithm function. ln x. Got it. Now the really tricky part. What's missing? Sine. Square root.
Cube.
And cubing?
Yeah.
Okay. So our next class, we'll practice 3 more, the other 3. And then the class after that, we'll have a quiz. Okay? And the quiz will look just like this. You'll have to do that very same way. Okay, guys? All right, let's put those away. You can leave your flashcards out in case you need them in your notes. Okay, I still have a bunch of cookies up there if anyone wants a cookie.
Yeah. Pass those cards, guys.
You can grab a cookie.
Oh.
You can get up and get a cookie if you want a cookie.
I'll just wait till we get through this.
Here we go. Let's look at, we are ready on page 10, part 3, D and E. Okay? So D and E are very, very similar. What do D and E have in common? What shape are they? We are on page 10 of our notes.
Parabola.
Problem 3D and 3E, and I heard somebody say
Parabola.
they're parabolas. how do I know they're parabolas?
Is there both squares?
Because they're x squared. And my BFF says that if it's squared, it's a parabola. Right? Now, on my note card, x squared looks like this. I have put a plus 1 inside the parentheses with the x. What does that do? Moves me. Which way does it move me?
Left.
This one goes to the left. This one goes to the left. I made a little cheat sheet for you the other day, hopefully you wrote that down. When it's inside the problem, inside the parentheses, then it is moving right and left. Plus is left, minus it would be right. So, here's my picture. That's all I have to do, is draw my curve, 1 unit to the left. Alright, now what does this one do? This is a whole different ballgame. This one goes down 1. You have to see the difference between that and that. Look at it. See the difference? This is a left and right. That's an up and down. Okay? Now, I want you to just, okay, so this is a page we're on right now, right? I just want you to go like that. Don't turn any pages, just turn it back it over. And you'll see it says extra practice 1.3. So let's see if you can sketch one ABCD. Let's start with one ABCD. So step 1, here's A. Step 1. What shape are we shooting for here? Which BFF is that?
Square root.
Square root. And I know that a square root looks like that. This one has moved. Where has it moved? Left 2. So I'm going to put a dot at -2. And up and out, there it is. That's all there is to it. You gotta know your shapes. Know your rules about moving. And it's so easy. Now, what about this one? This one has 2 things happening. It will be the same shape, won't it? But now how is it moving? Right? 5, up 1. So 1, 2, 3, 4, 5, up 1. So that's the point 5, comma 1. And then up and out, just like always. Now C will be a different shape. What shape is C? Parabola. Moved.
Moves to the left. No, right. Nope. Down.
That's a down. That's a down. What would it look like if it were left or right? Wouldn't that 2 be inside the parentheses? That's a left and right. This is down 2. So it's my same old parabola, but it's situated down 2. Get in the habit, kids, of labeling your starting point. Alright, another big one. X minus 2 squared plus 3. Tell me about this parabola. Right 2 and up 3. So 1, 2, 1, 2, 3. And it's just a little parabola. Alright? I, J, and K. H, I, J, and K. H, I, and J involve a little bit harder shapes. Exponential, moved, down, one. So what does a regular exponential look like?
Zero.
It has an asymptote and a 0.01.
Yeah.
It looks like that. So now I have to draw that very exact same picture, but down one. So that asymptote is actually going to be here at -1 now, as it was at 0. And it came down 1. Where's the dot going to be? It was at 0, 1. Where's it going to be?
Zero.
At origin. And there you go. Do not let the picture get you all confused. Just move everything down 1. Alright, this is a logarithm, a natural logarithm, ln. How has it moved? To the left 2. So I like to have an idea what the original looks like. The original has an asymptote at 0, a point at 1, 0, and it looks like that. I missed my point, but you get the idea. That's the original. Now what are we doing? We're taking everything left 2. So that asymptote, which was at 0, is now going to be at -2. Right? Everything's left 2. And that point, which was at 1, is now going to be at -1. 1, 2. And there it is. Okay? What's that one? What's cubing function look like? Really? And the normal squiggle is from the origin. But what's happened here? 2 units, right? So now my squiggle point is going to be right here. Remember, if you have a hard time drawing this, think of a parabola opening down. Think of a parabola opening up. And then only use this part and this part. That is your how about this guy? Yep. Wait, what? Yes, there is. Do you have any idea what would make that happen? If we, and that's, it's true of all these things. If we put a negative out in front, like that right there, that would tip it upside down. Same thing with this one, same thing with this one, put a negative out front, it's gonna tip you upside down. All right, we'll cover that base when we get to it, but yes, so yes, that can happen. Not without a negative though. All right, this is our square root again. Tell me where it started. We did some of these a minute ago. Where is our square root starting? To the right 3 and up 4? So 0.3 comma 4, and we go up and out. Right, now we need to go back to our notes, our 4. Turn the paper, no, turn the paper back over. Notes right down here, page 10. In the graph, what are called piecewise functions. Not like piece. Word piece or something. These are called piecewise. And they're called piecewise because they are graphed in pieces. So these are going to consist of part of a picture, maybe part of another picture. So how does this work? Well, let's look at the first graph. You are really going to need a pencil with an eraser here. When you're doing some erasing. Okay, so we're going to start. And these steel case markers are great, but they smell. Can you smell the fumes? Steel case marker. All right, first thing I want you to do is take your trusty pencil. And whatever is over here, in this case it's 3, I want you to draw a squiggly line through that. So in this case it's a 3. When I look at C right below it, it will be at 0. I'm going to do a squiggly line at 3. That is where my graph is going to get broken. That's where I'm going to have a piece over here, and I have a piece over here. Okay, now we're just going to temporarily forget that. And we are going to sketch this. Well, you know what that looks like. What is that? It's a V. And it's not added or subtracted or anything, so it just starts at the origin, right? And it's just my V. Now notice that the V hits my squiggly line. It hits right here. That is where my V is broken. Now, this tells me which part of the broken V I keep and which part I throw away. This is the part I keep. I keep the part where X is bigger than 3. So does that mean I'm going to keep this piece of the V or this piece of the V? Am I going to keep right or left? What's that say? Greater than. Is it greater than that way? So I'm going to keep this part of the graph and I'm going to erase this. That's gone. I threw that away. I kept only the part of the V that's on the right. This is the right side. Greater than. Okay? Now, this dot right here is going to remain open. Any idea why that's an open dot? Look up here.
Because
Why do you think that's an open dot? Because it's not or equal to. Okay. Now, let's graph this one. What shape is that? That's a parabola, right? So I'm gonna sketch in my parabola. Notice that it also hits the squiggly line. Since that's an or equal to, I'm gonna go ahead and color in that dot. Would you be okay with that? And now my parabola is in two pieces. There's a left piece and a right piece. Which piece do I keep? This tells me what to keep. I keep the left side. So I'm gonna keep all this. I'm gonna throw away that. And then, you don't have to do this, but just for good measure, I'm gonna erase my squiggly line. And that is the answer to the question. Notice it's in two pieces. A right piece, which was an absolute value piece, and a left piece, which was a parabola piece. All right, let's do C. We'll do B last, because it hurts. Let's do C. What's that? That's a linear, but instead of going through the origin, like a normal linear would go right through the origin, right? This one has been dropped down to. So it's going to be my regular line. Oh shoot, I forgot my squiggly. Where's my squiggly this time? Gotta have that in there. Notice that my red line, which is this line right here, hit the squiggly right there. Open or closed? Open. Keeping right or left? Keeping, this tells me what to keep. So I'm keeping right, getting rid of left. Alright. This is a little bit tricky, we haven't talked about that yet, but you know what this is. Isn't that another line? With a slope of 3. So we would have to graph that. Let's see. What's its y-intercept? Isn't this its y-intercept right here? So then we'll just count up 3 and over 1, up 3 and so here is that line. That got one closed. Keeping left or keeping right? Left. You can leave your squiggly line, guys. Don't worry, you can leave it. I'm gonna get rid of it so you can more clearly see. Do you see 2 pieces? A blue piece and a red piece. When you do these, you guys, we're getting ready to do B, which is a little bit harder. But when you do these, you'll always have an open dot and a solid dot lined up on top of each other. Never 2 opens, never 2 closed. You have 1 of each. Now, I don't know who will be on top, but you'll have 1 of each stacked on top of each other. Okay? All right, let's look at the next one now because it's a Can you tell me? What do you notice about it?
Three.
There's 3, which means there are 2 break points. So when I draw this one, I'm gonna have 2 squiggly lines. Where are my squiggly lines going to be? 2 and 0. Yep, so I'm gonna have 3 pieces. So I got a squiggly line at 0, a squiggly line at 2, and now my graph is gonna be in 3 different pieces. Alright, tell me about that guy right there. What is he? He's linear up 1. So instead of being linear through here, he's linear through here. Now, he does hit both breakpoints, but the only one I care about for him is this one. You see that? Look right here, it tells you. I only care about that one right there. So that he hits right here. That will be an open dot. And then I'm going to keep which way? I'm going to keep left or right? I'm going to keep left, which means this is going to get erased. This one's tricky. Literally, it is y equals 3. Can anybody tell me what y equals 3 looks like? That isn't on your note card. That's exactly right. I saw 2 or 3 of you that are going like this. Y equals 3 is this line right here. That's the line where y equals 3. It hits both squiggles, but I only care about where it hits 2. So that's right here. Ooh, that will be an open dot. And I will keep which way? I'll keep the right. So far, you have this red thing going down this way, and then the blue thing going out that way. Okay. What shape is that? That's parabola. Okay? Not moving, so it's right at the origin. So. What? I don't think that's the what?
Origin.
Oh, that's not the origin. Thank you. Thank you very much, Mr. Tipton. It's not the origin. He says, what are you doing this for? I know I do it. Here, this is better. There we go. How's that? Is that better? Now, I care about this time where it hits both of them. So it hits this one right here. And this time, that dot will be closed. And then it hits up here somewhere, and that dot is also closed. Now, what part of the curve do I want to keep? The part in between? In between? Look here, does that make sense? I want to be in between. So I'm going to get rid of this part over here. And I'm going to get rid of this part up here. And that's my answer. Now, look at it. You see an open dot and a closed dot on top of each other? Twice? That's how it will always be. Alright, turn it back over. Let's see if we can get even. See how far you can get with one E. Got your parabola at the origin? Open it up. Hitting the squiggle right here and hitting with a solid dot. And then keeping left, so erasing this. Alright, what shape is that? Linear, up 3. So instead of going through the origin, going through up here, and hitting the squiggle right there. Remember, the normal linear would go to the origin. Red 3. That would be an open dot. And which part do I keep? To the right. So all this goes away. I can erase my squiggle if I want. And looky there. What a nice, great, awesome picture. Alright, you do F. See what you can do with F. The last one we get done. You do F, I'll do it up here. In F, you're going to have 2 lines. These are both linear. Both do that. I'm John Landless.
And of course, you don't feel right.
No. Okay, are you wrapping 2x? I hope so. Thank you, Mrs. Wheeler. All right, 2x. Right side, that's what I got. What about you? What did you do with this one? It's another line, but where is it? Down to? Gabby?
How did you get that graph for 2x?
A line with a slope of 2, so up 2 over 1. Up 2
you ever for one-year one? What would it look like to make it like go more length?
This could be interpreted either way. Notice that if I go down two, but if I go right two, that would be right two, it's right two, that would be right there. So really doesn't matter. All right, good job. By the way, 1-3 is due on Wednesday. 1-3 due on Wednesday. Tomorrow or whenever I see you again, we practice for our BFF, which is coming up.